So we're going to be talking about the phases of the moon. Eclipses will come later. I'm sure you recognize all the different shapes that the moon is making here. By the end of this, you're going to be able to explain how it's happening using the models. Before we can start using the models and talking about the moon, it's important that you have certain vocabulary. Remember that scientists use words in a particular way to represent information that may be different than the way that you see these words in other parts of your life. So it's important that you understand the science-based vocabulary words here. We're going to be talking about the phases of the moon, not a phase that you're going through, as you grow up and become a teenager, but instead a phase is the different appearance of the moon according to its changing position, and really that should be its position relative to the Earth and Sun, but that would have made it a really long definition. Waxing means growing or becoming larger. So rather than waxing your car to make it shiny, the moon, or the shiny side of the moon that we see, waxes or grows larger over time, and we use this word to explain what's happening to it over time so we know what phase it's in. The opposite of that is waning or growing smaller. If growing and smaller seem like an oxymoron to you, then you can say getting smaller or becoming smaller, but growing smaller is really what I'm going to put. Now we have two words that talk about the amount or shape of the shiny side of the moon that you can see. When the moon is a crescent, it's anything less than half a circle. In contrast to that, when the moon is gibbous, it's anything more than half a circle. So if we look back at these pictures in the introduction, this down here is obviously a crescent, and so is this, but so is this and this and this, and even this is a crescent. It's a little bit less than half a circle. This right here is where it becomes a half a circle. Over here, it's a little more than half a circle, so this moon is gibbous, so is this one, and this one, and this one, and this one, and even this one is gibbous. This technically is still gibbous. This is probably full right here. So you can see that there's a variety of crescent moons and a variety of gibbous moons, but all of them are either less or more than half a circle. All right, so you are going to now be using the models. Please set up your models exactly as you see here in the picture. We've got the Earth on the Earth spot. Your sun is a cup, okay? Mine's a ball, but yours is a cup. And I have the moon in between on one of the dots. Notice that I've got this arrow to show you which direction the moon will go as it starts to revolve. Now, it's very important to realize that no matter where the moon is located around the Earth, the white side will always face the sun. That's because the white side of the moon represents the shiny white portion that we see in the sky. It becomes shiny because it's reflecting the sunlight. Outer space has no sunlight. The shiny white side must face the sun because that's where the shininess comes from. You're going to see that depending on where around the Earth the moon is located, we're going to see different amounts of the shiny white side, and that's what causes the shapes that we see in the sky. So please set your moon directly between the Earth and the sun, with the entire shiny white side facing the sun. This is set up for a new moon, but right now, we're sort of positioned hovering in outer space here. We are not seeing what the moon looks like when you live down here on the Earth. We really need to see what the moon looks like on the Earth. So, this is where I'm so clever. You're going to turn your paper on the desk, leaving the model set up on the paper. Turn the paper so that, see how my eye is lining up with the Earth and then the moon behind it? If you position your eye right there behind the Earth, and then if you need to move the Earth out of the way, you should see that you see only the black side of the moon. That's a new moon. Only when you don't see any of the shiny side, you see all of the dark side. This is how the model is going to help you understand how the moon looks in various locations when you're standing on the Earth. We don't care about outer space. We just want standing on the Earth. All right. So now that you've seen the moon when it's new, you're going to place the Earth back on its spot if you had moved it. Then you're going to revolve the moon one spot counterclockwise. Notice that the shiny white side is still facing the sun. Then again, you're going to turn your paper. This is different now. Notice that before we saw the sun behind the moon, now the sun is off to the side, but it's still visible to us in the sky. Now we're going to look at the moon again from the direction of the Earth. Here we see the first white crescent starting to show. It's gone from being all black to being partially white, so it's growing. It's a waxing crescent. See here, this location is the waxing crescent. It's grown from nothing to some white, and it's less than half a circle, so it's a crescent. Okay, every time as we go forward that you move the moon, you're going to also turn the paper and look at the moon from the direction of the earth, even though I don't have a picture for everyone. Okay, so we're going to revolve our moon one more spot. Please now turn your paper and look at the moon from the direction of the earth. It's vital that you look at it from the direction of the earth, otherwise you're never going to catch on. Okay, again, we're going to revolve one more spot. Turn your paper so you can look at it from the direction of the earth. You should be seeing more than half a circle here. This is a waxing gibbous. It's growing larger. It's more than half a circle. Oh, you know what? Let me back up a second. Here you should see only half the moon, okay? Half the circle. But notice that the name is called first quarter. We see half the moon. It's called a quarter. What gives? Well, here's why. Notice how far around it is. 1/4, halfway, 3/4, all the way. So even though we see half the moon, it's 1/4 of the way through the cycle, which is what makes it called the first quarter. That's important for you to know. All right, so we're going to pass waxing gibbous since we talked about it. You're going to go all the way so that the moon is on the opposite side of the earth from the sun. You'll find that when you turn the paper and look at it from the direction of the earth, that you see the entire shiny white side of the moon. That is a full moon. It is lovely and spooky at the same time, depending on how you feel about it. Now we've got the waning gibbous moon. It's moved one spot. Now we're seeing less of the moon each time, but still it's more than half a circle, which makes it a waning gibbous moon. Be sure to turn the paper and look at the moon from the direction of the earth. Now we have the last quarter moon. When seen from the direction of the earth, you're going to see half the shiny side, but it's 3/4 of the way through the cycle. So turn the paper, look at it from the direction of the earth. We're going to revolve one more spot. This is now the waning crescent moon. When you turn the paper and look at it from the direction of the earth, you will see that you can see only a crescent of the white side, so it is a waning crescent moon. And finally, we return to the new moon, and so we've now gone through an entire month. It takes about 28 days to go through the cycle of the moon.